Education, University of Canberra, Professor Barney Dalgarno, Honorable Professor, Lecturer, distinguished guests, and all participants. Good morning from Universitas Negeri Malang. In the name of Allah SWT and all praise belong to Him who has blessed us today to attend the series of virtual collaborative webinars. Referring to our university motto, the excellence in learning innovation. Educational and learning innovation is our mission to achieve the educational goal of Indonesia Golden Generation 2045. The webinar is organized by the Faculty of Mathematics and Natural Science, Universitas Negeri Malang, and the Faculty of Education, University of Canberra. The purpose of the webinar is to enhance quality research in science and mathematics education, and also in STEM education. In the third collaborative seminar series, we held the competition of 3 minutes research presentation by Indonesia master and doctoral student in mathematics education. It is my pleasure to welcome you all to this event. And the webinar series 3 with the theme competition of 3 minutes research presentation is the culmination of determining and announcing the webinar of the competition that has participated by Indonesian master and doctoral student in mathematics education. Through this webinar, we will gain new insights about education, especially in mathematics education, which is being researched by Indonesian and Australian researchers communities. Therefore, I would like to take this occasion to express my appreciation to our speaker today. First, Dr. Subanji, M.Si from Universitas Negeri Malang. The second, Ms. Tamsyn, PhD candidate from the University of Canberra, Australia. He is a Director of Student Advancement in Gold Creek School, Canberra. My appreciation should also be addressed to all competition participants coming from many cities in Indonesia, from Medan, Jakarta, Palembang, Makassar, Semarang, Binjai, Tanjung Pinang, Jember, Malang, Sidoarjo, and so on. And also all non-competition participants, come from many universities or institutions in Indonesia and various countries, such as from Australia, Indonesia, Malaysia, Timor-Leste, Thailand, India, Pakistan, and China. This event will not be well organized without the support of various parties and contribution from the participants. I especially thank to the organizing committee, Department of Mathematics, Faculty of Mathematics and Natural Sciences Universitas Negeri Malang, and thanks to Dr. Siti Patahudin from the University of Canberra. They have prepared this event so that it can run well and successfully. In the name of Allah Subhanahu wa Ta'ala, Bismillahirrahmanirrahim, I hereby officially open the competition of 3-minute research presentation 2021. Finally, I hope that this event will provide practical knowledge, insight, and experience, and improve the quality of Indonesia academic culture, and strengthen the Indonesia-Australia partnership. Enjoy this event, and I hope that you all will have a great time. Thank you all. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Professor Dr. Hadisono, Master of Science, for your kind welcome. I also would like to invite the Executive Dean of Faculty of Education, the University of Canberra, Professor Barney Dalgarno, to deliver a welcoming speech. The distinguished Professor Barney Dalgarno, the time is yours.
Thank you very much. Look, I'd like to begin by acknowledging that those joining in Canberra are doing so on lands traditionally owned by the Ngunnawal people of Australia, while I'm joining from Coolman, west of Canberra, on lands traditionally owned by the Wiradjuri people. And I'd like to pay respect to elders of these Aboriginal nations, past, present, and emerging. On behalf of the University of Canberra, I'd like to welcome you to today's webinar, which is the third in a series presented in partnership with the University of Malang. I'd like to also thank Professor Dr. Hadu Suwono, Dean of the Faculty of Mathematics and Natural Sciences, the University of Malang, for his ongoing support for this important collaboration. I'd like to also thank Dr. Siti Matahuden from the University of Canberra for all of her work in helping to establish the webinar series, as well as the 3-minute research presentation competition that we are here to celebrate today. The previous 2 webinars were attended by or watched by nearly 1,000 people. And as of yesterday, we had received 400 registrations for today's webinar, which may include some watching live, as well as others planning to download the recording. And those people, as we just heard, are from a number of countries in addition to Indonesia and Australia: Malaysia, Thailand, Pakistan, Timor-Leste, and China. I'd like to congratulate the 42 Masters and PhD student participants for the quality of their video presentations. It is a tribute to the reach of these webinars that we have participants from 8 different provinces and 16 different districts. Most importantly, I'd like to congratulate our 20 finalists who we will hear from today. I'd like to also thank our 2 guest speakers in anticipation of their presentations to come shortly. So I'd like to hand over now back to our host to introduce our first speaker.
Thank you, Professor Barney Dalgarno, for your kind welcome. But before we start the main session, to all contestants and participants, please pay attention to the information of the 3 minutes video competition. We would like to inform you that every winner in the competition is a different person. No contestant will receive more than 1 prize, and the decision of the adjudicating panel is final. Thank you. Now it's time for us to start the main session of this event. Respected audiences, ladies and gentlemen, the first session in this webinar is the speaker's presentation from Universitas Negeri Malang and the University of Canberra, while the second session is the presentation of the finalist video contestants of 3 minutes competition. And let's jump to the first session, which is the speaker's presentation from Universitas Negeri Malang, and it will be delivered by Dr. Subanji, Master of Science. So ladies and gentlemen, allow me to invite Dr. Subanji, Master of Science, to present his presentation. Pak Banji, the time is yours.
Ibu Latifah.
Thank you.
Pak Banji, mungkin sebelum mulai saya mau izin dulu.
Ya, Pak Dekan. Terima kasih, Pak Dekan.
Good afternoon, Prof. Barney. Sorry. I'm sorry, has permission to leave this meeting because I will give a guest speaker in Universitas Muhammadiyah in Surabaya. I'm sorry to leave this meeting. Bu Siti, saya minta izin untuk leave ya, karena saya
terima kasih Bapak. Thank you so much.
Terima kasih Pak Dekan.
Assalamualaikum.
Thank you.
Terima kasih Pak Dekan. Waalaikumsalam warahmatullahi
wabarakatuh.
Terima kasih Bu Latifah. Ya. Good afternoon, Bapak Ibu, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
I
wabarakatuh.
will explain about research development in mathematics education. Bu Latifah, nanti kalau slide saya tidak jalan, saya diberitahu ya.
Baik Pak, siap.
Okay. I will start from the essence of learning mathematics. What is the essence of learning mathematics? The essence of learning mathematics is learning to think and reason. Learning mathematics is used to develop thinking and reasoning. How to develop thinking and reasoning in learning mathematics? The answer is to provide challenging activities. The hope is students become critical, creative, communicative, and good problem solver. The last goal that students are able to face global challenges. Therefore, the study of thinking and reasoning is very important in mathematics education. What has been developed in mathematics education research? I have developed several research in mathematics education as well as being a research map for students. The first about pseudo-cooperational reasoning. We find three theories about pseudo-cooperational reasoning. The first, substructure incompleteness in the assimilation process. The second, the substructure incompleteness in the accommodation process. The third, incapability of the thinking structure. The second facts, the form of constructor error. Pseudo construction, construction whole, misanalogical construction, mislogical construction. The third focus, the defragmentation of thinking structure. We find the apparent scheme, the knitting of scheme, restructuring of analogical thinking, and restructuring the logical thinking. This find for as a basis for developing learning. We can develop of mathematics teaching and learning. This example, my find about pseudo-cooperational reasoning thought process in published in journal Korean. We find three theory, the first theory, the second theory, and the third theory. The first theory, the substructure incompleteness in process assimilation. The incompleteness thinking substructure in accommodation process. The third theory, incapability of the thinking substructure. The latest research, creative model and controversial reasoning. Creative model. We find three level creative model. The first, imitation. The second, modification. The third, construction. Oh, sorry, ini modification. Construction. This research model creative has published in International Journal of Interaction. Okay, imitation level, the student only able to imitate solution strategy that has been obtained. Modification level, the student able to change the solution strategy as problem change. The third construction level, the student able to build new strategies in solving problem. My student refine the creative model communication combination. The refine being works on by doctoral student. Open problem and follow up this fine. The first refine the creating model level might be pre-imitation, transition, and others. How to apply creative model in learning mathematics? What strategy can be used to increase the creative level? We also study about controversial reasoning. How do sudden reason when solve to controversial problem? This is example controversial problem. The student think 3 plus 3 equals 6. Represented 3 apple, combine 3 apple, we get 6 apple. This procedure can be doing in fraction. 1/3 plus 1/3. 1/3 represented 1/3 square from 3-sided. The plus represented combine 3 square, combine 3 square, we get this picture. The result 2-sided square from 6 square. This procedure reasonable but wrong. What is wrong with this construction? This is controversial problem. Controversial problem. 3x plus 2y. There are cases of teacher who give example. Who example x is book and y is pencil. If I replace x is course, x is course, and y is course, and are combined in one check. Combined in one check. This is. Then I get 5 cow and goats. The result 5 cow goats. Write 5x y. What's wrong with this problem? This is controversial problem. The other controversial problem, algebraic form. X minus 3 per x plus 1 equal x minus 3 per x plus 2. We can cross product. The result x plus 2 times x minus 3 equal x plus 1 times x minus 3. We can cancel x minus 3. We get x plus 2 equal x plus 1. If we cancel x, we get 2 equal 1. This is contradiction. What's wrong with this problem? This is a controversial problem. the controversial problem. This is root negative 2 square. If we turn to the right, the result negative 2. To the left, the result 2. Contradiction. What wrong with these problems? This is controversial problem. Controversial problem are problems that create a gap between the concept that have been constructed and the problem that are being solved. Reasoning in controversial problem solving conceptualizes controversial reasoning. Right? CR level. We find CR level. The first level initial, the second level exploration, the third level clarification. The initial level, the sudden are able to recognize controversy, but not able to explore the component of problem. Exploration level, students are able to recognize and able to trace the component, but they are unable to clarify. The third level clarification, students able to clarify problem using reasoning that makes sense, come up with various reasons, can be used to justify solution. We have open problem and follow up. The first, refine CR level to improve higher order thinking skill through CR, integrating CR into mathematics learning. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Warahmatullahi wabarakatuh.
Thank you, Dr. Subanji, Master of Science, for your interesting presentation. Now, we would like to invite the second speakers from a PhD candidate of the University of Canberra, Tamsyn, to deliver her presentation. Tamsyn, the time is yours.
Thank you for having me. Thanks for having me. Thank you to the organisers and other presenters, and also thank you to Dr. Siti Padahudan. She is my supervisor. Today, I'm going to present action learning as a methodology for teacher professional development and as a data collection tool as well. I am currently in the final stages of completing my doctorate, which used action learning to help teachers design self-regulation pedagogy. I'm a secondary school teacher myself and a school leader. My research interests are bridging the gap between education research and classroom practice. There is a lot of research, strong research-based practice out there, and lots of passionate teachers, but they don't always join together. So I'm passionate about bridging this gap. I'm also keen to build self-regulation learners and support teachers to continually improve their practice and their pedagogy. So my research question is, what is the impact of action learning as a professional development tool to improve self-regulation pedagogy in secondary mathematics and science education? So before I describe action learning, I'll just give you a brief overview of the rationale for my study, just to provide some context. So through reading the literature and from my own personal experience, I learned a lot about the self-regulation and that it has historical presence and that it's important. Self-regulation is an active and a constructive process. It's essential for productive learning, building self-efficacy, and for lifelong learning. It was also learned through the literature was that self-regulation needs to be taught, but also that it can be taught. And at this level, self-regulation is relatively simple. Where it becomes more complex is that there are many constructs of self-regulation. We've got motivational, metacognitive, social, emotional, and cognitive. And then there are also theoretical models and strategies designed to promote self-regulation, such as goal setting and assessment and feedback. But there are also many different understandings of these. So I won't take you through all the background of self-regulation for the sake of time, but I'll take you straight to the complexity that the teachers are facing. And that is that teachers are typically don't teach self-regulation effectively, which was found in the literature. They're not promoting goal-setting environments and are not teaching self-regulation skills explicitly. They favour implicit modelling of self-regulation. And explicit teaching is fundamental for self-regulation learning. As I said before, the pedagogy and the theoretical models exist for self-regulation, but they're not accessible to teachers in easy to implement formats in the classroom. And the pedagogy of self-regulation requires the teacher to understand the theory of self-regulation, which teachers don't often have the time to explore. The research on self-regulation also analyses teacher practice, but it has not involved teachers in the conversation, whereby they're contributing to the pedagogy of self-regulation. So teachers are the enactors of all pedagogy and the ones with the authority in the classroom. And therefore, it's really important that they are involved in the development of pedagogy and new pedagogy. We need to learn from teacher knowledge and experience. Research and solutions need to be context specific and relevant to the teachers who are enacting and practicing those particular pedagogies. Teachers also, we also need to consider their pedagogical beliefs, and teachers need time to link new practices to existing practices. And that is through that time of reflection so that they can attach those new pedagogies to their pedagogical beliefs. So then my research aim, my study aims was to develop the professional discussion and development on self-regulation for teachers and involve teachers in the design of self-regulation pedagogy. And then also provide teachers with the time to reflect on their practice and find context-specific solutions for their classes and for their students. So in order to engage teachers in professional learning on self-regulation, I needed an approach that could help teachers to reflect on their practice, consider self-regulation, and consider its place in their pedagogy. And action learning is a group work method that has been proven as an effective complex problem-solving process, but in non-educational settings. It rests within the philosophy that the answer to the problem inherently rests with the problem holder. In my case, or this case, being the teacher. So in action learning, the model that I use, which is the World Institute of Action Learning model, there are 2 ground rules. And the 2 ground rules are that statements can only be made in response to a question. And this rule is to help the participants gain a greater understanding of the problem and not simply state the first thing that comes to their mind. Drives that deeper thinking. Then the second rule is that the coach has the power to intervene to help the group stay on task and use questions. The coach is not involved in the discussion or the solutions. They are there to assist the group. And in this study, the coach is to keep the group on task and to check in on their effectiveness and to help the group identify patterns, commonalities, and differences. So in action learning, there are 6 components. The first one is that there is a problem. The problem is specific to the people who hold the problem, and specific to those people in the group. The group is there to have shared learning and collaboration. The group needs to be responsible for the actions. Questions drive that deeper thinking in action learning. And then that learning is not just about the actual problem of self-regulation, but it's also learning about how to work together as a group and it also transpires into learning long after the action learning has occurred. And then the coach, as I said before, is to help support the group. So my study design, and this is how I used action learning, my context was mathematics and science teachers from a 7 to 10 secondary school. So my study started, I had an action learning trial, interviews, then I had an information session on action learning and self-regulation for the teachers before we went into 3 iterations of action learning. And if you like, you can think of action learning as an action research cycle. So the first action learning meeting or workshop, the participants come in and start reflecting about their professional practice, thinking about self-regulation, and then they plan for actions, and then they act on those, observe what was happening, and then a month later they'd come back into the second action learning meeting when they would again reflect on their practice, plan for new actions based on their previous challenges, and then come up with new actions to then trial for another month before coming back into the third action learning meeting. And action learning can happen over 2. Group members have time to reflect on the previous selected solutions and actions in their class. So if I come back to the research question, which is what is the impact of action learning as a professional development tool in self-regulation pedagogy and secondary education, specific to mathematics and science, is that the first thing action learning resulted in was that it provided the participants of my study with the opportunity to reflect on their practice and experience. They freely discussed their challenges and solutions. They had empathy for each other and were very vulnerable at opening up about the challenges they were having. They came up with solutions specific to their classes, and they also developed self-regulation pedagogy. So the contribution to professional practice is that action learning as a professional development tool and as a data collection method. Self-regulation, a pedagogical framework, was developed from combining the teacher knowledge and experience from my study with the literature and the findings in literature on self-regulation. And just a final reflection, action learning is one way to engage teachers in professional development. But the key things that I took out of my study using action learning is that participants and professional development for teachers need to factor in time for teachers to really reflect on their practice so that they can unpack their pedagogical beliefs and attach new ideas to their existing practice. They need time to collaborate, and it needs to be context specific as well and relevant to the challenges they are facing in the classroom so that those solutions are relevant to them and usable to them. So thank you for listening. Thank you for having me. And I will stop sharing.
Thank you, Tamsyn, for your nice sharing. Unfortunately, we have a limited time for today's event, so there is no Q&A session for the speakers' presentation. Thank you for all speakers, Dr. Subanji, Master of Science, and Tamsyn.
Thank you.
Before we continue to the next session, to all participants, please fill the attendance list in the link attached on your screen. Thank you. Okay, thank you. Ladies and gentlemen, now we come to the competition of 3 minutes research presentation video. And here are the videos from 20 finalists of the competition of 3 minutes research presentation. And the voting for the like of the videos will be closed at 11:50 a.m.
Hello everyone, my name is Putri Dayana I'm from Mathematics Education Postgraduate in University of Malang. Creative thinking has a very important role in people's life in the 21st century. Creative thinking is having carries much idea and gives new contribution, so the student can solve the problem easier. Creative thinking must be supported by good emotion, and everyone has a different intelligence. Most students, when emotional is not good, will tend not to try and be lazy, while students with good emotional will get satisfactory work result. In consequence, emotional intelligence is one of the success stipulation. Some research states that emotion or positive moods will facilitate creative and integrative thinking, which is an important aspect of creative thinking. So, how is the mathematical creative thinking process in terms of the emotional intelligence of undergraduate mathematics students? Okay, this study aims to find out how the mathematical creative thinking process is viewed from the emotional intelligence of undergraduate mathematics students. Due to the COVID-19 pandemic, learning is done online. Learning is done in 4 steps. In the first step, students fill out a questionnaire with Google to find out the level of emotional intelligence in each student. If the level has been met, then proceed to step 2, namely giving a creative thinking test according to the level of emotional intelligence. Then, in the third step, students fill out a questionnaire via Google as a substitute for an interview. And the last step is data analysis. This research is qualitative, so that the results show that high emotional intelligence can think creatively mathematically key, while emotional intelligence can think creatively mathematically under. So, it is necessary to familiarize students to think creatively in solving problems.
My thesis is about antinomy reasoning in knowledge construction. Relation reasoning is the process of recognition or obtaining meaningful relationship between related bits of information in the form of similarities or difference. Alexander et al. Suggests that relation reasoning consists of 4 types, namely analogical, anomaly, antinomy, and antithesis reasoning. Analogical reasoning is related to similarities, and others are related to difference. Except for antithesis, all 3 reasoning are needed when learning mathematics. Because analogical reasoning has been widely used in mathematics learning research, I focus on relation reasoning related to difference. Winder suggests that the anomaly reasoning first consists of identification, interpretation, and adaptation, each of which consists of object recognition, anomaly detection, concept formation, anomaly abstraction, highlight attribute, and anomaly adaptation. Initially, in the interpretation phase, there would be a difference between the anomaly and antinomy reasoning. In my research, I found that the antinomy reasoning phase has the same 3 phases as anomaly reasoning but with different detail. The main difference is in the interpretation phase, namely the formation of concept and conception, which result in the adaptation phase. In the adaptation phase, only antinomy adaptation occurs. Mainly, in the process of construction knowledge based on a posteriori, in the action stage, low-level object recognition occurs. In the process stage, there are the advanced object recognition, antinomy detection, and concept and concept formation. In the object stage, the concept and low-level antinomy adaptation occurs. Finally, at the scheme stage, advanced antinomy adaptation occurs. Thank you.
Bismillah, Assalamualaikum warahmatullahi wabarakatuh. Hello, good afternoon everyone. The Honorable to all of jury at 3-minute research competition. My name Agus Ma'ruf. I'm a master student of Mathematics Education, University of Malang. Welcome to my research presentation. I will presentation about my research with the title, The Development of Student Worksheet Based on Islamic Context to Increase Students' Mathematics Comprehension in Matrix Material for Class 11. My focus research. There are 3 my focus research. The first one is mathematics comprehension, about the importance math comprehension. The second one, student worksheet based on Islamic context, about my product and my treatment to improve math comprehension. The last one, matrix material, about math material in grade 11 senior high school, what I took for the development of Islamic context based student worksheet. And then the aims of my research. The development of valid and effective student worksheet to increase students' mathematics comprehension in matrix material for class 11. My research method. The research method used in this research is R&D, or research and development, with quasi-experiment. The result of my research. There are 2 the result of my research. The first one, the result of my research. The Islamic contextual based worksheet in matrix material is valid and interesting. The Islamic contextual based worksheet in matrix material is effective to improve student mathematical comprehension. The proof of the results, valid and interesting. The result of the validation of material expert with a score of 3.49 valid category. Teaching material expert with a score of 2.97 with valid category. Validation of Islamic context expert with a score of 3.38 valid category. Teacher ratings with a score of 2.95 interesting category. Assessment of small group test student with a score of 3.34 very interesting category. And assessment of file test student with a score of 3.10 interesting category. And then effective, the experimental class and gain score of 0.411 with medium category, which is better than the control class and gain score of 0.073 with low category. I think that's all about my research, presentation. Thank you. Alhamdulillah. Assalamualaikum warahmatullahi wabarakatuh.
My name is Desi Rahmatina. I would like to present my study about the student statistical reasoning of variability in cognitive perspective. Let's take a look at the bar chart on the left. All of the data we gathered in shown in the bar chart. For example, the display of student information. In this bar chart, what do you think? Can we conclude from the test result of students from the 2 groups? Well, group 1 saw the result of a mathematics test using the problem-based learning, while the second group used the inquiry-based learning. How do you make a decision when choosing a better learning process? As you can see from our data, the average score of the student from both group is 80. Each group is composed of 30 students. Incorrect reading of the bar chart can lead to incorrect decision making. In reading statistical information, the reading has to make sense. Statistical reasoning is commonly encountered in everyday life, so it's important to use a cognitive component in statistical reasoning. Variability is at the heart of statistical reasoning. Through this study, I introduced cognitive a lens in statistical reasoning of variability. Cognitive is a combination of communication and cognitive. There are 4 cognitive components that can be used when performing statistical reasoning, namely what use, visual mediator, narrative, and routine. What use can also be said as keyword or vocabulary. There are 2 types of what use, namely literate what use and colloquial what use. Furthermore, there are 2 visual mediator, namely symbolic and iconic visual mediator. Narrative in the form or rule related of variability can be used of variability that can show how far the data is spread from the mean. Here, the rule of visual mediator is very decisive to support narrative. In addition, routine are a procedure used when performing statistical reasoning. There are also 2 routine, namely exploratory routine and applicability routine. Thus, this study, I recommend the use of visual mediator because of its importance and essence when doing statistical reasoning about variability. Thus, this research can contribute to student, educator, and decision maker to be able to emphasize of use cognitive component when doing statistical reasoning. Thank you very much.
PISA fever shocked Indonesian education world. We do not talk about the PISA tower in Italy, but what we are talking about the PISA, the international triennial report that has seemingly become the arbiter of education quality around the world, including Indonesia. As you can see in the graph, the unexpected result showed that the poor performance of Indonesian students over the last 2 decades of participation. Let me invite you all to think, why did it happen? Indeed, there are some causal factors behind it. First, students are not used to working on hard problems. Second, teachers tend to only provide some material and exercises at the low level. Third, limited learning resources provided by textbooks and the bookstores. Therefore, to overcome this sad situation, the government had made some initiatives, such as reforming the curriculum and making PISA as an international benchmark for education in Indonesia. A concrete step also proved this issue by eliminating the national examination with national assessment, the minimum competitive assessment, which focused on literacy and numeracy. The term numeracy in MCA corresponds to the definition of mathematical literacy in PISA, which is described as understanding how to use mathematics in real-world situation and how to use it to possibly to make the best decision. We need to hand in hand to support our government by collaborating with teachers to design and implement PISA items in learning and assessment using local context-based stuff. When we are talking about the context, the unwanted situation like COVID-19 is a global issue and engaging for students to learn mathematically. As you know, there are a lot of COVID data spread across various media regularly, and other effects of COVID-19 are worth studying. Let me give you some example. Look at this picture and let me ask you, what do you notice? What do you wonder? What's something you can learn from this? Can you imagine how a layperson can read and reflect it mathematically and correctly? Do you think our students can read it as well? So it is an obligation for us to teach them how to read and reflect it mathematically and correctly. At the same time, it will raise student awareness. They will be more adaptive, aware of dangers of COVID-19, and able to survive during and after COVID-19. Thus, we have an idea to develop a PISA common task that valid, practical, and have potential effect on student mathematical literacy. The question is, how does the development process occur? We use the design research with the type of development studies. This study includes a series of activities such as preliminary and design to produce the initial draft. Then the prototype item design process continue with the task experiment using focus group discussion. And in the end, the PISA-like resulted after prototyping or formative evaluation. All data will be collected and analyzed descriptively through observation, interview, document review, and test. Again, it is appropriate for our students to learn things close to them related to real-life situation. At the end of the day, they must learn to apply what they know to attract all they want. Thank you.
Statistical literacy plays an important role in people's life in the 21st century. Statistical literacy is ability to understand and critically evaluate statistical results that permeate our daily life. Statistical literacy involves two reading skills, understanding and interpreting data. A statistically literate person must have the ability to understand and criticize data or information obtained from other people and formal institutions. As a result, it is critical to equip a student with basic skill in reading and understanding data, interpreting data, and even presenting data in the form of table or graphs. Because these are basic abilities that students must possess as a foundation for progressing to higher education level or as proficient when they are already in the workforce. The importance of statistical literacy in the life of the student is still not in line with the reality in school. Most students still have trouble comprehending and analyzing data presented in the form of table or graphs. Some studies suggest that students have difficulty in understanding and presenting data in the form of histogram. They are also very weak in describing data. Many things can affect students' statistical literacy, one of which is the cognitive style. Cognitive style can affect a student's statistical literacy because in solving a problem, each student has his or her way to acquiring, processing, storing, and using information. Previous research has described students with different cognitive styles as having different abilities in understanding and solving problems. It explained that cognitive style can also affect student statistical literacy. Based on several studies that had been conducted, studies that discuss how the process of statistical literacy of students in solving statistical problem review from cognitive style has still not been found. In previous study, it is still rare for researchers to discuss the description of statistical literacy process carried out by students while solving problems. Information regarding the description of how students' statistical literacy process in terms of understanding data, interpreting data, and communicating data is still rarely discussed, and it is considered difficult to obtain. Knowing the description of the statistical literacy process carried by students will be greatly help us as a prospective teacher to understand how statistical literacy process is carried by students in solving problems, so that classroom learning can be more meaningful and adjusted in order to further improve student statistical literacy. Therefore, the study aims to describe the process of student statistical literacy in solving statistical problems because of difference in cognitive style that students have.
Assalamualaikum warahmatullahi wabarakatuh. My name is Canberra from the Magister Program of Mathematics Education Universitas Negeri Malang. On this day, I will present my research plan about the development of ethno-mathematical questions to assessing critical thinking skills on geometry topic at junior high school level. The importance of critical thinking along with the development of the time in the 21st century where people will be faced with a variety of increasingly complex situations and problems. Of course, a thought is needed that is able to analyze the cause of the problems, how to respond, and provide the right solution, so as to be able to be called a critical thinker. However, the importance of critical thinking is not balanced with the situation, which shows that there is still a need to optimize critical thinking in students One of the things that researchers do is by making observation at one of the junior high school at Jakarta showing online learning. Teachers rarely give evaluation to students who measure their critical thinking. The form of evaluation given by the teachers is only in the form of measuring basic skill in mathematics, and one form of assessment to measure this is by giving questions that require them to think critically so as to develop their abilities. An important topic in mathematical discussion is geometry, but the fact in the field that the importance of geometry studies is still a lot of difficult experience by students because the object of study that is abstract and difficult to make visualization. And an effort to solve problems in geometry studies, one way to relate everyday problems, then the problem associated with relief can be presented through ethno-mathematical. By integrating the diversity of cultures in Indonesia, is expected that is also one way to promote Indonesian culture to students. Question of the from this research is how to develop ethno-mathematical question to assessing critical thinking ability in geometry topic at junior high school level that will have valid, practice, and effective criteria. The research using by the ID model and to obtain the validity of the researcher will validate the question developed to material expand. Then to obtain practically, the researcher will be tested to the teachers and students. And then the product certified effective if the score from S critical thinking indicator is at least 2 based on the scoring rubrics. Enough for me and thank you for your attention. See you.
Did you know about the term mati, matika? In Bahasa Indonesia, mati means death. That is the term used by most students in Indonesia to describe mathematics. This is because mathematics is considered a scary and difficult subject to understand. Moreover, in 2020, there will be a significant change in education in Indonesia, which was triggered by the spread of COVID-19 virus. The government decided that all face-to-face teaching and learning activities in school be replaced with online learning, which make math lesson more difficult to understand. In a preliminary study at St. Albertus Catholic High School Malang, it was found that many students had difficulties during online learning, especially mathematics. From the 95 respondents, 54.8% said it was difficult to concentrate during online mathematics learning. The difficulties that continue in the learning process will put pressure on their mindset and triggers the symptom of anxiety known as math anxiety. Mathematics anxiety has several symptoms including negative emotional, mental, and or physical reaction to mathematical thinking process and problem solving related to mathematics. Students who have math anxiety end up with lower math competence and achievement. Mathematics anxiety levels are classified into 3 categories, namely high, medium, and low categories. The appearance of math anxiety is also categorized into 2 conditions. First, math anxiety that arises during online learning, and math anxiety that appears while doing the assignment and tests. The purpose of this study is to categorize the level of anxiety and then provide appropriate treatment based on research strategies for reducing math anxiety in post-secondary students by Laura Lossi to reduce the level of anxiety. The instrument in this study was adapted from the research instrument of mathematics self-efficacy and anxiety questionnaire by Diana K. May, which has been adapted to the condition of online learning. The grouping of mathematics anxiety levels is determined based on distribution of respondents' answer.
My name is Aulia Rahmilubis from Mathematics Education Postgraduates in Universitas Negeri Malang. So now I want to tell you about the result, the effect of using learning videos on students' mathematical problem solving ability. Problem solving is a process to tackle a problems that is faced to solve the makes some strategy. According to Polya purpose 4 steps, problem solving among them, understanding the problems, devising a problems, carrying the problems, looking back. So the student even difficult to translate what's were knows from matters what's were given, and they are already know what that is request, but didn't know given conclusion the answer. The difficulties faced by these students become a problem for students in learning mathematics. An interest for student and can given student interest in learning mathematics. One example of learning media is interactive learning video. Video that is used as learning tools to make as interactive as possible, so that students are interested in the learning and don't feel bored with the learning process. The result in Korea show that videos can be more effective medium than text to present real life situation. Learning video is one way to learn for easier internet access either at home, at school, or through a smartphone. Video is an effective form of audiovisual media to use. So teachers should also be taught by video learning. Video also be used from almost all topics, types of learning, and every domain of cognitive, affective, psychomotoric, and interpersonal active. The duration videos will be present about 15 until 20 minutes. The video uses the management of audio and visual elements to convey appropriate material. Study use pre-test and post-test as a test measure the ability before after treatment. In the design of there are two groups of study and consist one group of experience using learning video and one control group. Hope this study can explain the effect of using learning video on students' mathematical problem solving ability so that they can improve the quality of teaching and learning. The results of the study are also expected to be useful for teachers, research, and students. Thank you.
The construction of professional noticing of teachers to students' mathematical thinking is important to master. It can be used as a basis for making intentional instruction decisions. Furthermore, many research have developed professional noticing framework. In this research, I use framework of Jacobs et al. They introduced the construction of professional noticing of children's mathematical thinking as skills that consist of attending to children's strategy, interpreting children's understanding, and deciding how to respond based on children's understanding. Research result using the framework of Jacobs et al., for example, Amandur et al., Nagel et al. My first activity that is I still have to explore the result of the other research on the characteristic of professional noticing using Jacobs framework. Mathematical creative thinking is a subcomponent in mathematical thinking. A study of mathematical creative thinking, characteristic of professional noticing to students' mathematical thinking using the Jacobs framework, and a more in-depth search on the characteristic of professional noticing was used as material for the hypothetical theory of the characteristic of professional noticing to students' creative thinking as a result second activity. Mathematical creative thinking is combination of originality, fluency, and flexibility. These indicators are measured through mathematical investigation. Mathematical creative thinking using investigative tasks and the concept of professional noticing of the prospective teacher to mathematical thinking lead to a study of professional noticing of the prospective teacher to students' mathematical creative thinking in completing investigative tasks as a result of the third activity. The third component of professional noticing is how the teacher responds to students' thinking. Many research on how teachers respond to students' thinking. For example, inviting students to share the method. In my research, it is explore more deeply how teachers respond to students' thinking as additional material to characterize a student's mathematical thinking skill. This is the fourth activity. The result combination of activities 2 and 4 are material for the hypothetical theory of the characteristic of professional noticing to students' creative thinking with specificity in responding to students' thinking skill. This is the fifth activity. The result of combination of the third and fifth activity is the ultimate goal of the study, namely the characteristic of professional noticing to students' creative thinking in completing investigative tasks.
When you hear the term literacy, what is the first thing that comes to your mind? Many people would say that it is associated with skills such as reading, writing, and performing simple calculations. While the statement is not wrong but only limited to a simple understanding of literacy, because nowadays the understanding of literacy has developed and become one of the important topics discussed in education. In mathematics itself, there is also a term called mathematical literacy. Many experts have defined what mathematical literacy is, but clearly, we can say that mathematical literacy assists individuals to know the role that mathematics play in this world and to make well-founded judgment. Individuals with a well mathematical literacy can use their mathematical knowledge effectively in dealing with problems in everyday life that will be very helpful for them. Seeing the importance of mathematical literacy, the facts show that the achievement of students' mathematical literacy in Indonesia is still low, especially in PISA report. I have also conducted preliminary research on 60 secondary students by giving them PISA-like problem. The results show that only 8 students can solve the problem correctly, while the other give wrong answer, and even worse, they don't understand the problem. So it is necessary to conduct a more in-depth research regarding which aspect of mathematical literacy that students' performance is less good and why. My thesis will study about this, examining it based on personality type, because from the study literature that I have done before, I found that each individual has a different response when facing a particular problem called personality different. One theory that classified personality into several types is the Keirsey personality theory. This theory classified personality into 4 types, namely guardian, artisan, rational, and idealist. Each of them has a different characteristic. So by the end, my thesis will contain a detailed description of students' mathematical literacy in solving PISA-like problem based on personality type. It is expected that the upcoming research will be used as a guideline in order to create an appropriate learning strategy in order to improve students' mathematical literacy. Thank you.
First, I want to ask you, where do we live right now? Of course, we are in the 21st century. What skills do we need? We need higher order thinking skills for global competitive that are provide complex and challenging problems. There are 2 levels of thinking skill based on Bloom taxonomy. First is lower order thinking skill as plus, and second is higher order thinking skill as follows. Lots includes remembering, understanding, and applicating, while HOTS is an ability at high level in the process of cognitive that are analyzing, evaluating, and creating. Improving thinking skill is important goal for education, and Indonesia is no exception. But the fact HOTS of Indonesian students is still low. It can be seen from the result of TIMSS and PISA. In the TIMSS 2015, Indonesia was ranked 44th out of 49 participants. Even though HOTS is important in learning mathematics, Because why? With HOTS, students can have a good ability for solving their daily life problems. The success of students having HOTS was influenced by two factors, internal or external factor. One of the external factors is the role of teacher in learning and teaching process. But teachers often believe that stimulating and developing HOTS is only appropriate for high-achieving students. Meanwhile, we know that LOTS and HOTS, they are a skill, right? So the skill can be trained and developed through the learning process. The learning process carried by teacher is intended to maximize student HOTS. Therefore, the learning process must be HOTS-based problems. HOTS include collaborative, authentic, unstructured, and challenging problems. HOTS-based problems must be mastered by teacher. Because why? Students at every level of achievement, both of low achieving student or high achieving student, need to improve their skill. Based on this background, the research was conducted to explore teacher skill to create HOTS-based problems. In line with this aim, the research used descriptive qualitative approach. That's all. Thank you.
Covariational reasoning is needed to construct, interpret, and model the function of a dynamic event. A dynamic event that contains the notion of the rate of change is a central concept of calculus, an essential foundational course for mathematics students. Covariational reasoning is also a necessary skill for the interpretation of function in the real world. Based on these statements, covariational reasoning is an ability that students need to represent and interpret the changing properties of a function situation. The idea of covariation is used as the basis for understanding function in mathematics. However, based on several studies, students' abilities are still very weak in construction function graphs. Some of them are: students have difficulty understanding the visualization of a graph of a function which is a model of a certain event, and difficulty understanding the concept of a function as a relationship between two variables, as well as having difficulty seeing that the graph of a function is a description of a covariation problem. Covariational reasoning is a higher order thinking activity that requires a person to use his reasoning power to solve problems properly and correctly. So, can a person's ability to deal with problems or difficulties affect covariational reasoning abilities? Meanwhile, argumentation can be seen as the result of the reasoning process. Argumentation consists of claims or statements for justification or refutation that are supported by evidence or facts. Argumentation plays an important role in instilling the basic scientific concepts, which are the core of reasoning ability. Through these statements, the question arises about how does one argue when solving the covariation problem? Does the structure of a student's argument in solving a covariation problem affect their covariational reasoning ability? Furthermore, affect their ability to understand the basic concepts of calculus? This study seeks to contribute to the solution of learning function in a meaningful way by using a covariational approach for undergraduate students through argumentative analysis. This research is qualitative. Analysis of the structure of students' argumentation on covariational reasoning was carried out after determining their level of adversity quotient.
Problem solving is one of the mathematical skills that must be learned by students. This is in line with the objective of learning mathematics, which includes developing communication, reasoning, problem solving, connection, and representation skills. Problem solving is important for students in solving everyday problems in class or in everyday life, including the international scale evaluation, namely PISA. PISA, Program for International Student Assessment, is an evaluation or test in 3 areas of ability, namely science, reading, and mathematics to 15-year-old students who are randomly selected from various countries, which are held every 3 years. In 2018, Indonesia was ranked 74th out of 79 countries. The difference in achievements between students in cities and villages in solving PISA tests, which also has an effect on determining a country's PISA score. Thus, more specific research is needed by comparing Indonesia's students in urban and rural areas. Problem-solving skills in mathematics require a critical and systematic mindset is closely related to students' metacognition activities. Students who are skilled in knowing their metacognition show the ability to think more strategically in solving problems. Effective problem solving can be obtained by providing opportunities for students to apply metacognitive strategies when solving problems. Students who manage their cognitive activities well are able to handle tasks and solve problems well too. The level of students' metacognition in solving mathematical problems is tacit use, aware use, strategic use, reflective use. Students who have metacognitive knowledge will be much more successful in learning mathematics than students who don't have it. The application of metacognition strategies is to identify yourself about what you know, talk about what you think, record what you think, make plans and self-regulation, direct the thinking process and self-evaluation. Based on the background described above, the formulation of the problem is how is the profile of students' metacognition in solving PISA, space, and shape content. This type of research is descriptive research with a qualitative approach. Descriptive research is used because in this study it will describe or explain the variables to be studied. The approach used in this study is a qualitative approach because the data to be collected is in the form of words that are presented in the form of sentences. The description referred to in the study is this metacognition profile of students in solving the PISA, space, and shape content. Thank you.
At this time, I will present the result of research entitled Translation of Pseudo-Mathematical Representation in Solving Quadratic Function Problems. The reason why I chose this research for the first, based on preliminary study data, it was found that many had difficulty in translating representation in the material of quadratic function. Second, there is no much research on the translation of mathematical representation in Indonesia. And the third, this research is to improve BOSE's research in 2014. Translation is a process of transforming information contained in one representation or source to another representation or target. The ability of students to translate representation needed in the learning process. The process of mathematical translation can be described in 4 activities, namely unpacking the source, preliminary coordination, constructing the target, and also determining equivalence. This study aims to analyze and describe the process of translating mathematical representation in graphic to symbolic, table to symbolic, and verbal to symbolic in 11 graders of SMI 2 Malang in solving quadratic function. The research was conducted at SMI 2 Malang with the research subject of 6 children in 11th grade who had studied the quadratic function concept. The data collected included other results from mathematical translation tests and also interviews. Data analyzed focused on 4 mathematical translation activities, which were 10 categories according the translation components of representation like high, medium, and also low categories. The result showed that the mathematical translation of the quadratic function from graph to symbolic could be carried out well and completely by the high group subjects, while the medium and low groups carried out the process of translation activity stage quite well, but still had not reached the appropriate quadratic function. The mistake that the subject makes during the translation from table to symbolic are interpretation errors and also implementation errors. Mathematical translation from verbal to symbolic can only be done with the high group subjects, while the medium and low group do not indicate a target construction process. In translation from verbal to symbolic, the subject makes interpretation errors and also implementation errors. Thank you for your nice attention.
Mathematics and reasoning are two interrelated things, since reasoning plays a role in the mathematical problem-solving process. Reasoning can be interpreted as a thought process in connecting known facts or evidence to obtain a conclusion. Then, how about the importance of research on reasoning in mathematics education? Organization for Economic Cooperation and Development (OECD) explained that reasoning is one of the basic skills in mathematics which will continuously become a strategic problem in the future. So, the involvement of reasoning is an important problem that always exists in every mathematics learning. Well, there are several types of reasoning, one of which is analogical reasoning. Analogical reasoning is a reasoning process that maps a previously known structure to another structure that must be concluded based on the similarities between the two. There are four stages of analogical reasoning by Steinberg, namely encoding, inferring, mapping, and applying. Analogical reasoning is an important part of learning mathematics. The ability of analogical reasoning can help students in solving new problems using experiences they have previously gained. But Sarjogo's study explained that many research results state that students' analogical reasoning still tends to be low, which impact on the number of students who get low grades in mathematics and makes them dislike mathematics. Therefore, analogical reasoning is one of the main problems in mathematics education. In addition, several previous studies state that there were differences in students' analogical reasoning abilities. One of the reasons is students' intelligence, and one of intelligence theory is multiple intelligence theory by Gardner. That's interesting, since multiple intelligences has begun to be widely applied in Indonesia to determine the tendency of students' intelligence. But the intelligence used as review in this study are 3 types of intelligence among 9 types of multiple intelligences, namely logical mathematical, verbal linguistic, and visual spatial intelligences. Because these intelligences have contributed to mathematical reasoning and problem solving. Through analysis of students' work and interviews, this research will produce descriptive data related to students' analogical reasoning with logical mathematical, verbal linguistic, and visual spatial intelligence tendency in solving mathematical problems of analogical reasoning. So, hopefully this research can be useful for various parties, especially teachers as education practitioners. Thanks for your attention.
I'm Cynthia Leona Devi, a master's student at the Malang State University. We'll present a research entitled Students' Epistemological Belief about Mathematics in Realistic Mathematics Learning in Terms of Emotional Intelligence. Background in this research that most students consider it more important to get the right answer and memorize the procedure that has been given by the teacher. This view is part of the epistemological belief about mathematics. What the student believe mostly based on experience during learning mathematics. In this study, the learning experience in the select class is realistic mathematics learning. One of the determinants of success that is often overlooked is evaluational intelligence. Evaluation of epistemological belief toward FQ should also be considered. There are two research questions in this study, can be seen on the slide. This research method is a mixed method with an explanatory sequential design model. Quantitative research is used to answer the research question number one, and then qualitative research is used to answer question number two. The population in this study were students of junior high school Islamic Darussolihin Campur Darat Tulungagung. Sampling using purposive sampling, namely by paying attention to students who are taking the material quadrilateral. The sample in this study was the 7th grade students, as many as 42 students. The subject in this study were 6 students from each category of emotional intelligence. 2 subjects were taken with the up change category. The results of the quantitative analysis took the paired sample t-test at a significance level of 10%. So, a significant difference between key ATA before and after participating in realistic mathematics learning for students with high and medium emotional intelligence level. Meanwhile, for students with low emotional intelligence level, there is no significant differences. From the slide shown by the results of qualitative research, the 6 subjects experienced changes in certain subscale. 6 subjects had a varying belief on the time, understanding, and usefulness of mathematics subscale, and on the LT1 and LR1 step subscales, they have a varying belief. Others have non-availing belief. The recommendation in this study is to design an effective mathematics learning. Furthermore, similar can be carried out with larger respondent and elementary school or senior high school education level. Thanks for your attention.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sri Suryanti. I am doctoral student of Mathematics Education Department, Universitas Negeri Malang, Indonesia. I will present my research on problem-based mathematics tasks in Indonesia. Why and how mathematics tasks plays an important role in learning and teaching mathematics? There are several fundamental reasons. Teaching and learning activities in mathematics based on task mathematics completion. And student opportunities to learn, that is what they will be learning, is strongly influenced by the mathematical tasks, especially problem-based tasks. Yale in 2017 explained mathematical problems require several problem-solving strategies and not just the direct application of procedure. But the fact shows the many educators, when designing problem-based tasks, preciously produce routine exercises. So it must be clear which are problem-based tasks and which are routine exercise tasks. We focus the characterized problem-based mathematics tasks in Indonesia, mainly how teachers in Indonesia design problem-based mathematics tasks. This research was conducted on 240 teachers who have participated in the professional development program. During this program, teachers are required to develop problem-based learning material. The result of this research show exciting finding. Most teachers, almost 19%, do not understand how to design problem-based mathematics tasks. For example, if A and B vector, then determine the orthogonal scalar projection of E onto B. From this example, the teacher does not understand the criteria of problem-based task. And when getting this task, the most student will solve it directly using the orthogonal scalar projection formula because students have been given the formula before in their class. However, This task can be problematic for students who have not been taught the procedure or low ability students who have just learned the procedure but don't know how to apply it correctly. And with enough practice, this task can become a routine exercise for students. So that my further research will concern how to design excellent or good problem-based mathematics tasks which can be used as a reference for teachers in designing problem-based tasks in mathematics. Thank you so much. Wassalamualaikum warahmatullahi wabarakatuh.
How does the learning model occur if it is carried out without anyone guiding or assisting? Of course, we don't expect much from the learning outcomes, especially if learning is done not born of our own desires. This condition can be analogous to someone who wants to go somewhere new but doesn't have information and directions for the address. Lost, and this can happen to our students. Independent learning is one of the characteristics of online learning with asynchronous. Independent learning means learning that makes students independently determine and manage learning and determine their study time. The independent learning process makes students able to manage and regulate their learning process independently, which of course can be guided by the teacher in the process. However, independent learning in the context of the curriculum certainly requires a guide that contains learning objectives, learning materials and indicators that must be achieved, and learning steps that must be implemented. So those students don't get lost and can achieve their learning goals. A guide in the form of a module is needed, which can also function as a learning resource. Learning carried out by students through e-modules or electronic modules becomes an independent learning guide for students so that the learning process continues to lead to the achievement of learning objectives. This guide doesn't mean intervening students in their learning, but only as a guide to the goals that must be achieved in each learning materials present in the module. There are at least 3 requirements for a good module: having an attractive design with easy navigation, containing a menu structure as a ICAM, introduction, connection, application, motivation, and evaluation, and equipped with interactive materials such as video, audio, image, graphics, and animation. The research aims to develop an effective e-module ICAM model to facilitate the independence of students in learning mathematics. The e-module, which is the product of this research, at least facilitates students in learning because 1. E-modules become a guide in the independent learning of students to be able to improve the quality of their learning. 2. E-modules help students to understand well the subject of mathematics in accordance with the learning syntax that is prepared with the ICAM model. 3. E-modules are developed based on the research and development flow and are present in accordance with the structure and systematic of writing modules that are interesting and easy to digest. In principle, in this research, I want to know whether the use of e-modules is effectively used by students so that they can be helped in learning independently during online learning activities with the asynchronous model. Through using the modules that are developed in accordance with the material to be studied, students can learn independently to achieve their learning goals.
Assalamualaikum warahmatullahi wabarakatuh. Hello everybody, I hope we are all in good health. On this occasion, I would like to ask, have you ever experienced a controversial condition? Or have we as a teacher presented a controversial mathematics problem to students? I'm pretty sure that the answer is no. The big question is, why are students never given a controversial mathematics problem? Even though the research results are stated that solving controversial problems requires students' logical argumentation. Our preliminary study uncover that critical thinking component emerged when students solve controversial problems. Prospective teachers who have low critical thinking process will certainly not able to empower their students' critical thinking skills. These thinking skills are the main 21st century competencies that graduates must master. In connection with this challenge, the critical thinking process of prospective mathematics teacher must be optimized. This study was designed to explore prospective teacher critical thinking process when solving controversial problems. Participants involved were 200 prospective mathematics teachers from 2 universities in Malang, Indonesia. Among the participants, 19 experienced controversies. Furthermore, 3 participants were requested to explore the critical thinking process in solving controversial problems. Ensured by qualitative approach, data were collected through controversial questions, participant answers, and interviews. Findings suggest that participants' critical thinking process at the identifying stage link previously acquired concept, understanding concept, and conveying additional information. In the connecting stage, participants link the concept that have been obtained previously. In the applying stage, participants employ the concept to solve the problem. In the argumentation stage, the participant explain the answer that made correction on mistakes when arguing. Finally, the clarifying stage occurs when the participant check the answer. That is my presentation. Sorry if there are mistakes. Thank you for watching. Thank you very much. Wish you good health always. Assalamualaikum warahmatullahi wabarakatuh.
Let's give a big applause virtually to all contestants who are categorized as the finalists and delivered the great videos. Before the announcement of the winners, to all participants who have not yet filled the attendance list, please fill it in the link attached on your screen. And we will have a 5 minutes break for the panel meeting. Thank you. Jadi Bapak Ibu kita akan istirahat dulu selama 5 menit untuk meeting para juri.
There's something about the natural, the beauty of the random, something about the canvas of the sky, in the living sculptures of the land. And what of the considered, the breath taken by the composed, of what can be created with purpose, by design. Welcome to Canberra, where the natural and the composed beautifully intertwine.
It is a progressive city that attracts the high quality educated people who actually want to make a difference.
There's a thought, make a difference. You don't stumble upon change, you make it happen. You work for it, you design it. The University of Canberra is distinctive by design because Canberra was designed to be distinctive. Like our home, we're progressive in thinking, innovative in action, and push potential. Potential. What a great word. The blank page, the untouched easel, the breath before the big speech.
I think you really do need both the opportunity but also the ability to see and be able to imagine what you can be.
We could eat up a few minutes rattling off some impressive numbers, trying to quantify potential realised, but you probably won't remember them by the time this is over, and that's okay. We know what it's like in the real world. That's our sweet spot. And that's why we're driven for you to succeed in it. The real world knows that we produce market-ready professionals that make change across countless disciplines. That's why we're ACT's #1 university for graduate employment and starting salaries that might have something to do with workplace experience being at the core of our degrees. Or it could be our tight-knit group of educators, researchers, professionals and students bound by an ethos of progress, surrounded by the progressive. All we know is that being the university for Canberra, and not just the university from Canberra, makes us the University of Canberra. There's something about the natural, the beauty of the random, something about the canvas of the sky, in the living sculptures of the land, and what of the considered, the breath taken by the composed, of what can be created with purpose, by design. Welcome to Canberra, where the natural and the composed beautifully intertwine.
It is a progressive city that attracts the high quality educated people who actually want to make a difference.
There's a thought, make a difference. You don't stumble upon change, you make it happen. You work for it, you design it. The University of Canberra is distinctive by design because Canberra was designed to be distinctive. Like our home, we're progressive in thinking, innovative in action, and push potential. Potential. What a great word. The blank page, the untouched easel, the breath before the big speech.
I think you really do need both the opportunity but also the ability to see and be able to imagine what you can be.
We could eat up a few minutes rattling off some impressive numbers, trying to quantify potential realised, but you probably won't remember them by the time this is over, and that's okay. We know what it's like in the real world. That's our sweet spot, and that's why we're driven for you to succeed in it. The real world knows that we produce market-ready professionals that make change across countless disciplines. That's why we're ACT's #1 university for graduate employment and starting salaries that might have something to do with workplace experience being at the core of our degrees. Or it could be our tight-knit group of educators, researchers, professionals and students bound by an ethos of progress, surrounded by the progressive. All we know is that being the university for Canberra, and not just the university from Canberra, makes us the University of Canberra.
Okay, let's continue our agenda. The next is the announcement of the winners of this competition. And it will be announced by Dr. Sisworo, Master of Science, the Vice Dean of Faculty of Mathematics and Natural Science of Universitas Negeri Malang, for announcement of the first, second, and third winner. While the favorite winner will be announced by Ibu Siti Patahudin, PhD, from the University of Canberra. To all finalists, please turn on your camera. So, ladies and gentlemen, allow me to invite Dr. Sisworo, Master of Science, and Ibu Siti Patahudin, PhD, to give the announcement.
Bu Latifah, sepertinya Pak Sisworo masih belum masuk karena masih meeting sebentar. 2 menit lagi mungkin Bu Latifah.
Oh, baik. Jadi saya ulangi sekali lagi bagi para finalis, mohon dinyalakan kameranya, kamera Zoom-nya, kamera laptopnya, agar supaya nanti pada saat diumumkan pemenang, maka bisa kami spotlight. Terima kasih. Now we will announce for the favorite winner, and it will be delivered. It will be announced by Ibu Siti Patahudin PhD from University of Canberra. Ibu Siti, the time is yours, Ibu Siti.
Thank you very much. First of all, I would like to say congratulations to all of you. I have enjoyed the presentation. There are so many creativities and big ideas there. The winner for the favorite based on the likes or the viewers is Aziza Nurlaili Rahmawati. So which one is Aziza Nurlaila Rahmawati? Okay, thank you.
Aziza, apakah bisa dinyalakan kameranya, Aziza, sehingga panitia bisa spotlight video dari Aziza? Nah, ini dia pemenang atau juara favorit berdasarkan like di YouTube.
Selamat Mbak Aziza.
Selamat Aziza.
Yay.
Alhamdulillah, thank you.
Thank you, Ibu Siti Patahudin.
Dan hadiahnya apa, Mbak? Perlu disebutkan?
Hadiahnya, sebentar Ibu.
Dikasih tahu smartphone.
The prize is a smartphone. Smartphone. And Pak Sisworo, apakah sudah join di panelis? Bu Krida or Pak Asmi?
Belum, Bu. Belum. Okay.
Bentar lagi, beliau OTW katanya.
Okay, for the information, for the prize, the first prize and the second prize is from University of Canberra. And while the third prize and the audience favorite prize is from Universitas Negeri Malang. And we will wait for Pak Sisworo to announce the winner, the first, the second, and the third winner of the competition.
Assalamualaikum.
Waalaikumsalam.
warahmatullahi. Ada satu ngomongkan yang curhat pada sini.
Baik, terima kasih Pak Sisworo. Tadi berdasarkan meeting komite, Pak Sisworo selaku Wadik 1 dari FMIPA Universitas Negeri Malang dimohon untuk mengumumkan juara kedua dan ketiga. Sedangkan untuk juara pertama itu yang mengumumkan adalah Profesor Barney dari UC.
Baik, terima kasih. Bisa dimulai sekarang pengumumannya? Bu Latifah?
Silakan, Pak.
Baik, terima kasih. I'm here to announce the favorite winner of the competition of 3 minutes research presentation held by Universitas Negeri Malang and University of Canberra. Okay, the third winner is Alfiani Atma Putri Rosyadi with the research entitled Investigating Prospective Teacher Critical Thinking Process in Solving Controversial Mathematical Problems. And the second winner is Firda Mahrifatul Jana with the research entitled Lots to Hots. How do the teacher improve this skill? That's all. Thank you.
Thank you, Pak Sisworo. Ini adalah Alfiani dan Firda selaku pemenang ketiga dan kedua. Terima kasih Pak Sisworo dan Alfiani serta Firda. So finally, for the first winner will be announced by Professor Barney Dalgano from the University of Canberra. Professor Barney, the time is yours.
Look, I'm really sorry. I don't have the winner in front of me. Citi has messaged it to me, but I cannot open it. So I may need to ask Citi to tell me the first winner. Oh, here it is. The first winner, yes. The winner of the first prize in the 30-minute research presentation competition is Frenza Farouz Famansiar. Huge congratulations.
Thank you.
Thank you, Professor Barney, for the announcement. And maybe Bu Krida or Pak Asmi, could you highlight the video of Frenza? Siapa Frenza? Yang mana? agar supaya teman-temannya tahu pemenang pertamanya siapa. Apakah videonya sudah dinyalakan?
Sebentar, Bu.
Nah, ini dia adalah pemenang pertama dari 3 Minutes Competition Video, Frenza Virus Firmansyah. Selamat untuk Frenza Virus Firmansyah. For all winners, you will be contacted by the committee regarding the technical of getting the prizes. Jadi bagi para pemenang nanti akan dihubungi oleh panitia terkait bagaimana teknis pengambilan atau penerimaan hadiahnya. So, ladies and gentlemen, we finally come to the end of the competition of 3 minutes research presentation as well as agenda of the collaborative research webinar in mathematics education organized by Universitas Negeri Malang and University of Canberra. Before the closing, we would like to take all finalists and panelists pictures. For all panelists and finalists, please turn the camera on and the host will capture your picture. Thank you. Semua panelis, silakan baik peserta maupun panitia silakan untuk menyalakan kamera karena akan diambil gambarnya. Bu Krida atau Pak Asmi bisa membantu saya capture foto?
Ya, bisa Bu. Silakan diaktifkan kameranya. Baik. 1, 2, 3. Halaman pertama, lanjut ke halaman kedua. Satu, 2, 3. Kemudian halaman yang ketiga. Satu, 2, 3. Baik, terima kasih Bapak Ibu.
Sama-sama.
Terima kasih Bu Krida. So, ladies and gentlemen, we would like to say thank you again to all speakers and participants of the 3 minutes research presentation for today's event. Congratulations to all winners. We also would like to say thank you to all audiences for your participation. Hopefully, this webinar and competition will be beneficial for everyone. Before I end this event, to all participants who have not yet filled the attendance list, please fill it in the attached link. We will close the attendance list at 1 p.m. Ladies and gentlemen, thank you all and see you again in our next webinar or competition. Good afternoon and wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
warahmatullahi wabarakatuh. Selamat semuanya ya.
Terima kasih.
Terima kasih. Sertifikat